Good evening. Today is Wednesday, February the 3rd. Today in pre-calculus, we looked at the fourth type of conic section that we'll look at, which is the hyperbola. So I'll go ahead and share my screen and show you the basic formula and how we work to get the hyperbola graphed. Okay, so to start with the basic formula for a hyperbola, it's very similar to the ellipse, except what we have with the hyperbola is we have one plus and one minus square. So we have a situation where we have x minus h square over, in this case, I'll show you the a square where the x term is positive. So you have x minus h squared over a squared minus y minus k squared over b squared equals 1. Now, the difference here between the ellipse equation and the hyperbola equation is, of course, the ellipse has both of these terms square. So when you have the hyperbola, one will be plus and one will be minus. Now, and you can tell when you're looking at the orientation of the hyperbola, it will be oriented in the direction of the plus term. So in this case, this hyperbola is going to be opening to the side. So I will show you an example here. For instance, if we have a fairly simple example where we have, let's say we have x squared over 16 minus y squared over 9 equals 1. Okay, that's a general equation, or rather a standard form of the equation of a hyperbola. Once again, it opens to the left. So we'll go ahead and create the axis here. And notice in this particular case, there are no h and k terms. So the center of this particular hyperbola is at the origin. Now, you do the same thing with the hyperbola that you did with the ellipse. So you look at the number under the x term, which in this case is 16. You take the square root of that, which is 4. So we're going to go 4 to the right here. So we'll put a point here, which we'll call 4, 0. Okay, the coordinates there are 4 and 0. And then we'll go the same distance back to the left over here. That looks to be about the same distance. And we'll have a minus 4 and 0. Then the number under the y term tells us, in this case, it's 9. So we take the square root of 9, that's 3. So that means we go up and down 3. So we'll go up here to a point which is 0 and 3. And we'll go down to a similar point, which is under here, which is 0 and minus 3. Now, the difference here with the ellipse, you just connect the dots and you have your ellipse. With the hyperbola here, what you have to do, you have to draw a rectangle that goes through these 4 points whose sides are parallel. So say I'm going to come down like this. It's just a rectangle whose sides are parallel to the axis. So then I come across the bottom here through the bottom point like this. I go across like this. And then I come up over here through here. I go up like this. And then I come across the top here. I put some of these coordinates in a bad spot. But what I have here is a rectangle. Now, from this point, we draw our asymptotes. Now, the asymptote helps us to draw the hyperbola. So the asymptote comes through the corner of the rectangle here and through the center of the hyperbola. So it will come, basically will come down like this, and it will come down through the center, and it will keep coming down through the corner here like this, and so forth. And then the other one comes up from the other corner, from the third quadrant down here, comes through this bottom left corner, goes through the center, and goes through the upper right corner, and it keeps going on out like that. Okay, now when you get ready to draw your hyperbola, you come off of the asymptote like this, you come down, you come through the vertex, and then you go back along this asymptote here. And then the same thing happens over here. You come down through the vertex, and then you go out along that asymptote there. I'm missing the asymptote a little bit. Now, the foci here, you remember with the ellipse, the c square was equal to the difference between these two numbers in the standard equation. For the hyperbola, c squared is equal to the sum of the two numbers. So in this case, c squared is 25, which means c is 5. So then you go from the center out 5 units to the right, because this is the way it opens. So your focus is here at 5 and 0. And at minus 5 and 0. Okay, so that is the technique that you're going to use for graphing the hyperbola. Now, if you'll notice, if you look at your syllabus, tomorrow we will look at some of the situations where we're given characteristics and we have to go back to the equation. Everything we did today, we started with the equation. In most cases, the general equation. So tomorrow we'll look at characteristics, and we'll have to be able to go back to the equation. So, and then Friday we will be taking the mid-chapter quiz. Now, if you'll notice your syllabus, it says you're doing the odd problems on the mid-chapter 1 through 21. So you don't have to do every problem, you're just doing the odd problems. So if you have any questions, once again, I'll stop sharing here. You can pause and look at this. I will stop sharing here, and I will go ahead and terminate this recording. Once again, like I said, if you have questions, if you run into problems with your homework, send me an email and I'll get back to you. Otherwise, I expect to see the work on the mid-chapter sent to me either in an email attachment or into OneNote. So I hope are you doing well? And I'll talk to you. The next video will be next week after we've gotten past the mid-chapter.